So our final senior project this year was in creating a drone swarm for paralyzed surveying. So this would be applicable in like disaster zones or wildfires, areas where you want to get a lot of data as fast as you can. You put out drones and take images and surveil the landscape. So we'll introduce ourselves later, but our team is as shown. So yeah, again, our project objective is to use multiple drones in unison to all take images and stitch an image together with a low-cost solution and coordinating the path and planning of all of these drones. So the first real obstacle was localization. Usually you can use GPS when you're outside, but because we're developing this in an indoor environment, we had to come up with something else. So we also developed a cheap indoor localization using time-of-flight sensors, so a bunch of beacons around the room that we can get the distances between the beacon and the drone, and using some algorithms figure out where our drone actually is in the room in order to command a position to that drone. And then we get into multi-drone coordination.
Okay, so the drones we ultimately end up... Oh, hello. So the drones we ultimately ended up using are called teledrones. We've used these in previous classes, and what we found is that there's no easy way or built-in way to control multiple at once, which was a crucial part of our project because it's a drone swarm. So the hack that we pursued was using a bunch of these ESP32s as proxies that are plugged into the host laptop, which controls everything, and then connected wirelessly to each drone. And we found that this works quite well.
Yeah, so we've been working on this project basically all year, and all of our teammates up here split sort of the different components up into all of the separate modules that you see here. So we had some people working on the image stitching algorithm, a few of us working on sort of the ground station and being able to actually control all of these drones at once, and we also had some people working on sort of the localization and the path planning so that we'd actually be able to tell where the drones are and make sure they're going in the right places. But this is just sort of a diagram that shows all of the different components that we were able to work on throughout the year. So our goal was to be able to parallelize image stitching, and so the idea of that is that you have, for example, a giant map or some area on the ground, you have the drones fly over them and take pictures intermittently, and then whatever pictures they take, you combine them into sort of one larger image or panorama. And so these are sort of the sample images that we would take, so they have some overlap as the drones are flying over, but they're sort of individual pieces or portions of the larger image that we would like to create. And because, getting permitting for drones flying outside in a college is difficult, we did all of our testing indoors. And so this is sort of a printed out map of our MIT campus that we used as our tester. And so we had sort of a lot of different steps in our algorithm that basically when we put it all together, this is sort of the final image that we were able to create. And so you can kind of see some of the edges and certainly along the outside of all of the individual images that were used. And so we're very sort of proud of the fact that we were able to get a cohesive center image there. So. And yeah, this also worked with sort of multiple camera feeds. So since we were sort of targeting this drone swarm with multiple drones taking pictures, we needed to be able to combine the images of the different drones coming in. And so this is just an example of how we were able to do that with two feeds into sort of a merged panorama there. Yeah, and then do you want to talk about the demo?
Sure. So for the demo, should speak for itself. It's a video. So here we have two drones. This is a drone swarm of just two. They're both taking off and taking photos at the same time. And then we'll see on the laptop, which we'll show in a second, that the two video feeds are being combined to create a larger image. So as the drones move around, we map out a larger and larger area. And as you might imagine, two drones are much more efficient at mapping areas than just one. And here is that same demo, but seeing the laptop screen. In just a second, you'll see the individual images, and then they'll stitch together. So there are the two individual images. Then it's the drone stitching individually, and eventually it'll combine into one large image. this is the final result after a little bit of flying around and computation. And as you can see, it mapped out the entire map of Boston. That's it. Any questions?